Okay, number 16. Let's see what we got here. The student proves that every right triangle is an isosceles triangle by assigning the coordinates as shown below by using the distance formula to show that PQ and RQ, they both equal the same A. Well, if this point is 0, 0, P is 0, 0, and Q is A0, what's that distance right there? Okay, let's try it again. Let's throw some numbers in there. If this point is at 0, 0, and let's say this is at 4, 0, the point 4, 0, how far would that be there?
4.
To be 4, right? So, if it's A0, how long is that? A, right? So that has a distance of A, for sure, right? They don't tell us anything about R, though. They don't tell us anything about R. R could be there, it could be up here, it could be down there. They don't tell us anything about it. The student is saying that every right triangle is an isosceles triangle. So the student is saying that this is also, the distance here is also A. What? Right now?
On camera.
You just want to be on the camera when you walk by.
I really don't.
Why don't you wait till we're done
Man, it's
and
gonna
then go to the bathroom?
be all this come back here.
There you go.
We can edit it though, I think.
Yeah,
Okay, so you can edit it, right?
I could.
Okay.
I'm not going to.
In the middle of number 16.
Okay.
What's on done? All right. RQ does not need to equal A. They don't tell us anything about R, so it's not necessarily equal to A. So let's see. Any questions on number 16? Okay, moving on. 17. Quadrilateral PQRS is translated 6 units to the right and 4 units up. What are its new coordinates? All right, so each point is going to go 6 units to the right and 4 units up. So let's do this Q first. 6 to the right, 6, and then 4 up. So that would be Q prime after the move. Where's Q? Here we go. What is that? 3, 1? Q. Well, it's got to be this one then, right? Everybody okay with that?
Yeah.
Every point's got to go 6 to the right and 4 up. There you go. Any questions on 17 before we move on to 18? 18. Classify the triangle with vertices of the following coordinates. Let's just sketch this. -2, -2, 4, -5. And 1, 4. All right. Can we tell if it's scalene, isosceles, equilateral, or not enough information? What is scalene? What's a scalene triangle?
None of the sides are the same.
Isosceles is 2 sides equal, right? Isosceles. Scalene is what?
None of the sides are.
None of the sides are the same length. And what's equilateral?
All of the sides are the same.
All 3 are the same length, right? So all 3 of these answers have to do with the length of the sides, right? So we need to figure out the length of each side. This is R, this is S, this is T. How are we going to figure out how long each side is? It's the formula. The length between, the distance between 2 points. The distance formula is equal to x2 minus x1 squared plus y2 minus y1 squared. You need to memorize this formula. It will not be on the test, unfortunately.
That one?
Yep, this is formula. Write it down. Highlight it, put a star next to it, whatever.
Now we know how to, solve it.
Well, let's check RS first, the distance between R and S. So that would be 1 minus negative 2 squared plus 4 minus negative 2. What's minus a negative? It's plus, right?
Positive.
So that would end up as 3 squared plus 6 squared. So that is 3 squared is 9 plus 36. So that's the square root of 45, right? All right, so that's RS. Let's check ST now. Um, 4 minus 1 squared plus negative 5 minus 4. Three squared plus negative 9 squared, that's equal to square root of 9 plus 81. So that's a square root of 90. And what's the last one? TR. That is 4 minus negative 2 squared plus negative 5 minus negative 2. That's plus 6 squared, and that's plus, that's negative 3 squared, so that's 36 plus 9, square root of 45.
So we gotta do all that to solve it.
Just one problem, distance formula. You just do it 3 times. So what do we notice about the side lengths? Miss Evans, you okay? When I'm done, you can go. What do we notice about the side lengths?
RS, TR, are the same.
2 of them are equal, so what kind of triangle is it? Isosceles triangle, right? Any questions on 18?
No.
The distance formula will not be on the exam. So you gotta memorize that. Everybody got it? Okay. 19. What is the measure of angle D? This angle over here. What kind of triangle is ABC?
Equilateral.
Equilateral, right? Equilateral triangles are also equiangular. So what is the measure of each of these angles? They're each 60, right? 60 and 60. So if this is 60 degrees, what's this angle here? 20, right? Because they're linear. So 120. Triangle BCD is what kind of triangle? It's got 2 sides the same, so it's isosceles, right?
Yeah.
Well, in an isosceles triangle, we know the base angles are congruent. So this angle here has to equal this angle here. Those are the angles that are opposite the congruent sides. So if they're equal to each other, 180 minus 120 is 60 degrees, and I got to divide that equally between 2 angles.
30.
So they're each going to be 30 degrees. Questions on 19 before we move on to 20. So we're at 20. There is an error in the diagram. This is called the exterior angle, right? What do we know about the measure of the exterior angle? That's right. It's equal to the sum of the two opposite interior angles. So if I add this angle up here and this angle up here, it has to equal that exterior angle.
Sorry?
I don't know. So x plus 150 has to equal 145. That makes no sense, right? You can't have a negative angle, right? So that's the issue. Let's see which one it is. Somebody said, see, I thought I heard the exterior angle of a triangle must be greater than the remote. Nope. The exterior angle of a triangle must be greater. Nope. Exterior angle of a triangle must equal to a remote. Nope.
Nope.
Which one is it? Greater than? Exterior angle must be greater than. Oh, it is C. Must be greater than each of the remote interior angles. This angle has to be bigger than both of these. So it's C. Any questions on number 20? Okay.